Hello friends, welcome to Daring Marina YouTube channel. Today we will be discussing about shell plating, strikes and all and different types and all. Okay, shell plating, strike and what are the different types. Okay, plate is a rectangular shaped steel with a certain thickness. Okay, the most common place you can see plate in ship construction is in the main deck and the side of ship. Okay, plate is a rectangular shaped steel with certain thickness. Most common place you see the plate in ship construction is the main deck and side of ship. Shell plating. It is the outermost structure on the hull of a ship. Main purpose of shell plating. It is to provide watertight skin of ship. Based on the position of shell plating, most common type of shell plating are bottom shell plating, side shell plating and deck plating. Okay. Shell plating is the outermost structure on the hull of ship. Main purpose of shell plating is to provide watertight skin of ship. Based on position of shell plating, most common type of shell plating are bottom shell plating, side shell plating and deck plating. Side shell plating. It is a shell plating on sides of ship that forms watertight skin along ship side. Side shell plating is the shell plating on sides of ship that forms watertight skin along the ship side. Bottom shell plating. It is a shell plating on bottom part of ship. It is the shell plating on the bottom part of ship. We can say bottom shell plating form watertight skin of the bottom of ship. This bottom shell plating form watertight skin of bottom of ship. Deck shell plating. This is shell plating which forms main deck of ship. Shell plating means here deck shell plating means it is the shell plating which forms main deck of ship. Strike. It is the shell plating. You know that shell plating it is not made of a single plate. Here it is made of smaller sections of plate welded together. These plates are joined together and numbered in certain pattern. Strike means here shell plating is not made of single plate, it is made of smaller sections of plate welded together. These plates are joined together and numbered in certain pattern. Okay. Here each section of plate are placed according to fore and aft direction. It is called strike. According to above pick, we can say A strike, B strike and C strike. Shell plate it is not made of a single plate, it is made of a smaller sections of plate welded together. These plates are joined together and numbered in certain pattern. Example, each sections of plate placed in fore and aft direction called strike and placed to above pick, we can say A strike, B strike and C strike. Shear strike. It is the topmost strike of the side shell plating. Suppose the picture above is a side shell plating, then topmost strike is in the case of E strike is shear strike. Shear strike is the topmost strike of the side shell plating. Suppose the picture above is a side shell plating, then topmost strike is in this case is E strike is a shear strike. Keel strike means it is also made up of smaller sections of steel plate. It is made up of smaller sections of steel plate. This strike of plate that forms keel of ship is called keel strike. The strike of plate that forms keel of ship is called keel strike. Garboard strike. It is the first strike on each side of keel strike. It is the first strike on each side of keel strike. Suppose in this picture the keel strike, here the A strike is the garboard strike. Okay. Then ship hull framing system. So we have to discuss about ship hull framing system. As we already discussed, bottom shell may be transversely or longitudinally framed. Here longitudinal framing being preferentially used for vessels if its length is exceeding 120 meter and above. Then side shell is supported by frames which run vertically from tank margin to the upper deck. Side shell is supported by frames which run vertically from tank margin to upper deck. These frames are in form of bulb plates. Okay. Side shell is supported by frames which run vertically from tank margin to upper deck. These frames are in form of bulb plates. A ship is subjected to tremendous stress while at sea. We need to understand that a ship is subjected to tremendous stress while at sea. This requires special strengthening of ship plating. The shell plating of ship is not strong enough to withstand all the stress on its own and required to be framed towards its length. Shell plating of ship is not strong enough to withstand all the stress on its own and is required to be framed towards its length. The main stiffening members used in the ship framing are beam. It is a structural element that increases load bearing capability and avoids bending of structure under deck runs transversely. Okay, beam, it is a structural element that increases load bearing capability and avoids bending of structure. Under duct runs transversely. Frame means on the side shell plating runs vertically up and down. Floors means on double bottom, as we discussed. Then stringes means on side shell plating and longitudinal bulkheads that run horizontally, that is fore and aft. Stringes means on the side shell plating on the longitudinal bulkhead that runs horizontally on the fore and aft direction. Longitudinals, here it is the short name of longitudinal stiffener. They are mainly L-shaped frames found under deck, on side plating, on longitudinal bulkhead, on bottom plating and under tank top. Transverse means it is a short name of transverse stiffener. This is also found under deck. It is known as deck transverse. If it is found under bottom platform, it is known as bottom transverse. These run transverse but much heavier in construction than beams. Then similar stiffeners have different names in different places. For example, shell. Their weakened stiffening members will be frames and horizontally longitudinals. Support will be stringes for horizontal and web frames for vertical. Then bulkheads, we can say horizontal stiffening and vertical stiffening. Then here support will be stringes for horizontal and web girders for vertical. Deck means deck beam or longitudinal. Here support will be deck girders or deep frames. Then flat bottom. For the fore and aft direction there will be bottom longitudinals. In the transverse direction there will be bottom frames. Weekly support will be floors and keelsons. Same as in cam top, in tank top there will be fore and aft direction there will be upper frames, and transverse also there will be upper frames, and support will be floors and keelson. There are three types of hull framing system: transverse framing system, longitudinal framing system, combined or mixed framing system, or hybrid framing system. Okay, three types of hull framing system: transverse framing system, longitudinal framing system, or combined or mixed framing system, that means hybrid framing system. Transverse framing system. This system of framing is used in vessels of relatively less in length where longitudinal bending moments are not excessive. Okay, this transverse framing system are used in vessels of relatively less in length where longitudinal bending moments are not excessive. Framing system consists essentially of a ring of strengthening around the shell plating. Under deck beams are fitted at every frame space. On side plating, frames are fitted to stiffen the shell plating. The deck beams are connected to frames on every side by means of beam knees. Beam knees are very efficient in connection as compared to joining the beam directly to the frame. The deck beams are connected to the frames on the side by means of beam knees. Here beam knees are very efficient connection as compared to joining the beam directly to the frame. Here bottom structure is already discussed in the previous session. Here transverse framing system and all. We can say beam knee, deck beam, deck girder, center girder, transverse frame, floor, margin bracket and all. Longitudinal framing system. This is the most common framing method in long ship, usually if its length is above 100 meters. It is designed to withstand longitudinal bending moment. Main stiffenings are longitudinals which run full length of ship from forward to aft parallel to the keel. Okay, here main stiffeners are longitudinals which run full length of ship from forward to aft parallel to keel. An L-shaped stiffener which fit under the deck, on side plating, on bottom plating, under the tank top and longitudinal bulkhead as well. In addition to longitudinal deck are stiffened with deck girder and transverse. Side plating is stiffened with vertical webs and stiffeners. Here side plating is stiffened with vertical webs and stiffener. Here we can say longitudinal framing system. Here will be side longitudinal, deck longitudinal, side girder, center girder, bottom transverse, transverse web, bottom longitudinal and longitudinal bulkhead. Combined framing or hybrid framing system. As soon as it is a purely longitudinal framed ship is very strong in longitudinal direction, and transversely framed ship has tremendous transverse strength. The combined framing system have the advantage of both longitudinal and transverse framing system. We can understand that a purely longitudinal framed ship is very strong in longitudinal direction, and transversely framed ship has tremendous transverse strength. The combined framing system gives advantage of both longitudinal and transverse framing system. In this type of framing system, under the deck on bottom plating, vessel is longitudinally framed. Side plating is transversely framed. Here we can say transverse framing system. Here it is a hybrid. Here we have beam knee, deck beam, deck girder, center girder, transverse frame, margin bracket, and floor and all. So here it gives the advantage of both. What is bilge keel and its purpose? Bilge keel and its purpose. Bilge keel, it is a longitudinal structure that runs along much of the length down to lower side of ship hull to reduce rolling motion of ship. It is a longitudinal structure that runs along much of the length down to lower side of ship hull to reduce rolling motion of ship. Their purpose is to dampen rolling motion of ship, increase longitudinal strength, protect bilge while grounding. Bilge means bilge key. It is a longitudinal structure that runs along the much of length down to lower side of ship hull to reduce rolling motion of ship. Their purpose is to dampen rolling motion of ship, increase longitudinal strength, protect bilge while grounding. This is known as bilge keel. Here ground bar, bilge weight will be there. And construction details means bilge keys are fitted low down either side of ship hull. These are fitted either low down either side of ship hull. This bilge keel tapered gradually at ends to minimize hydraulic drag. Bilge keel tapered gradually at ends to minimize hydraulic drag. Bilge keel are not directly attached to hull plate. A ground bar is attached to bilge plate. Bilge keels are not directly attached to hull plate. A ground bar is attached to bilge plate. Ground bar to shell is connected by continuous fillet belt. Ground bar to shell is connected by continuous fillet belt. Ground bar to shell is connected by a continuous fillet belt. Ship stabilizers and different types of ship stabilizers. Okay, as the name indicates, the system which maintains stability of ship is known as ship stabilizers. Here in the picture we can see structure of a ship stabilizer. The purpose of stabilizer, it is to reduce the roll, that is sideways motion of ship. Normally modern big passenger ship and army ship having this type of stabilizer. Almost 70% of ship rolling can be reduced by this type of stabilizers. Ship stabilizers are of different types, but the actual function is same, to maintain the stability. From the name we can say stabilizers means to maintain stability. There are two types of stabilizers, fin type stabilizer and rotary type stabilizer. These stabilizers are shaped like aeroplane wings and extend out from the side of the hull in perpendicular fashion when in use. They can pivot up and down like ailerons on aeroplane wing. Consequently, as water flows over stabilizer, it can be turned upwards or downwards to exert dive or lift. Okay. Then when a sensor detects that a wave is pushing the ship one way, the ship systems automatically pivot the stabilizers so as to exert pressure in opposite direction. When a sensor detects that a wave is pushing the ship one way, the ship system automatically pivots the stabilizer so as to exert pressure in the opposite direction. When the ship is in port or when the seas are calm, the stabilizer can be folded back hydraulically into compartments along the side of hull. Stabilizers can be deployed independently, and so the ship officers have the option of deploying the stabilizers on one side of ship or both sides of ship the sea condition. When the ship is in port or when the sea are calm, the stabilizers can be folded back hydraulically into compartments along the side of hull. Stabilizers can be deployed independently, and so the ship officers have the option of deploying stabilizers on one side of ship or on both sides of ship that sea condition. Stabilizers do create some drag and thus can in theory reduce speed and fuel efficiency. However, any such loss has to be balanced against savings in speed and fuel efficiency resulting from reducing the ship motion. Stabilizers do create some drag and thus in theory reduce speed and fuel efficiency. However, any such loss has to be balanced against savings in speed and fuel efficiency resulting from reducing ship motion. This type of special setups mainly used in passenger and navy vessels and all. Okay, thank you.